Hello, this is Mr. Stansbury. I'm going to take you through the notes on approximating the area under curve. This first part of the video, we're going to show you how we can use the upper and lower rectangles rule to estimate the area under a curve. Okay, so there are several ways to estimate the area under the curve. So here's a basically the green is what we're looking for. We're trying to figure out how much area this is, and we've got this curved graph here, and we're trying to figure out what this area here is. Okay, so one way we can do that is with rectangles, and that's what we're going to take a look at here on this first video. And then the second video, we're going to actually look at how to do it with trapezoids. Okay, so with rectangles, what we can do is we can cut this area here into a bunch of different quadrants, so a bunch of different sections, I should say. So like on this case here, we took it and we broke it into 1, 2, 3, 4 equal pieces. So this is 0. Let's get on here. 0.25, 0.5, 0.75, and that's 1, right? So what we're going to do is we're just going to figure out what the area of each one of these rectangles is and add it all up, and that should give us an estimate as to how much area there is in this green section here. Okay, and then we'll also this is considered to be the this is called the lower rectangles, because it's going underneath the graph here, and this is called the upper rectangles. Too many P's. Upper rectangles. Okay, so what we do with this here is, again, we're going to try to find the area of each one of these things here. Okay, so the area of each one of these little rectangles here, or the total area, and we do this A subscript L, which means the area using lower rectangles is going to be the area of a rectangle is base times height, right? So this base here, if we're looking at this empty one here, this is from 0 to 1.25, so that's 1/4 times, now I'm going to write this here, the function at 0. Okay, so basically what this is going to be, this is going to be the height, because this is going to be the lowest section here. So the function at 0, which in this case here, to make this make a little bit more sense, is going to be, if we plug 0 into our function, here's our function, y equals x squared. 0 squared is 0, so this is really going to be 1/4 of times 0, which will give us 0, which makes sense because there's no actual rectangle there, right? And then what we're going to do is we're going to add this next rectangle in here. It's going to be 1/4, because that's the height from 0.25 to 0.5. That's a 0, by the way. And then this length right here. Now that length right here is going to be whatever this value is right here, and that value is at 0.25. So that's going to be the function, so times the function at 1/4 or 0.25, whatever you want to call that. Okay, so if we do that, that is going to be, so we're going to do plus 1/4 of the function of 1/4. 1/4 squared is going to be 1 squared is 1, 4 squared is 16. Okay, so we get that. That's the second part here. And then we're also going to add in this rectangle here, which is going to be 1/4, because if you'll notice, all these lengths right here are 1/4. That's why we're always starting with 1/4. And then we're going to do the function, this height right here is going to be the function at 1/2 or 0.5, whatever you want to call it. Okay, so in this case here, that's going to be plus 1/4 times 1/2 squared. 1 times 1 is 1, 2 squared is 4. Okay, and then we're going to do this last rectangle right here, which is going to be, again, the height is 1/4, 1/4 right here, and then times the function at 0.75 or 3/4. Okay, and sorry, these are all, oh, well, it's the function, so the function is the square piece, so I don't have to put the square on there. I just know that I have to square each one of these numbers, right? The 0, the 1/4. And in this case here, it's the 3/4. So this is going to be 3/4 squared. So 3 squared is 9. 4 squared is 16. Okay? Okay, so here's what we get. 0.25 times 0 plus 0.25 times a 16th, so forth and so on. And really, I guess we didn't even have to actually calculate these out, because we could have just done 0 squared, 1/4 squared, 1/2 squared, and 3/4 squared. You could have just left it like that, but we calculated it out. Anyway, we would go through and push enter, and we get that this the estimation of this area is going to be 0.21875. Okay, that's using the lower rectangles. Okay, now we can do the exact same thing with the upper rectangles, but there is actually a bit quicker way. So I'm going to show you how to do that a little bit quicker way on the lower rectangles, so that you see that we get the same thing, and then we'll show the same thing on the upper rectangles. Okay, so what we're going to want to do is we're going to want to get into our summation. So there's two ways to do that. You can do that, probably the most intuitive way is to do math, and then you just go down until you find the summation, which I think on this one is 0. There we go, summation. Okay, we do that and we get our little summation notation thing here. And what we want to tell this is we want to do, so x is our only variable they give us anyway. So we're going to start, basically it's like, what numbers are we putting in here? We're going to start at 0, right? And we want to go through and we're going to do 0, we're going to do 1/4, 1/2, and 0.75. So we're going to actually go through, we're going to go, I'm going to leave this blank for right now, because this is going to make more sense after we put in our little equation here. Okay, so what we're going to do is we're going to we're multiplying by the height, 0.25, right? And then we're going to multiply by, basically we're going to multiply by 1/4, well, 0 quarters, 1/4, 2 quarters, and 3/4, right? So we're going to put x is going to be our variable, and we're going to always do that, and we're going to divide it by 4. So we could do x divided by 4 like this, and that should work out fine. But just to make it look a little cleaner, I'm going to do this as a fraction. So we do our alpha y equals to get our fraction, and we're going to do x over 4. Oops, I did not do that right at all. Let's get rid of that 4 there and go x over 4. There we go. And then we don't want this there either. Okay, so we're going to do x divided by 4, and then we have to actually take that whole thing, and we have to square that, right? Okay, now, again, we're going to start with 0. We're going to do 0 quarters, 1/4, 2/4, and 3/4. So we want to start with 0 and go all the way up to 3/4. So we're going to actually, on this thing here, we're going to want to go, that's why we started at 0, and that's why we're going to want to end with 3, because we're going to go from 0/4 up to 3/4, just like what we did here. Okay? So we go through and we put that info in there, and as long as it's reading my square right, we should end up getting the same answer here, and we do 0.21875. So you can actually do the same info here instead of doing it all by hand. You can just put it into our summation notation, and then away we go. Okay. Now, upper rectangles, if you think about this, it's gonna really be the same thing, right? Each one of these is gonna be 1/4, and then our height on this one is actually gonna be this 1/4, and then 2/4, 3/4, and 4/4. So it's really gonna be the same exact equation, except for to do the upper rectangles, we're going to go, instead of starting at 0, height right here, starting at 0, we're gonna actually start with 1. Oops. So we're just going to go back over here, and we're just going to change it to 1 to 4 instead of 0 to 3, right? Because we're starting with 1, putting in 1/4, and then we're going to go all the way up until we get to, oops, oh man, there we go. We're going to go all the way up until we get to 4/4, and then that should give us the calculation of our upper, what we call the upper rectangles. Okay, so we do that and push enter, and we get 0.46875. So instead of doing all this calculation in here by hand, we can actually do it on our calculator. So we get 0.46875. Okay, so here's our lower rectangles, here's our upper rectangles, and if you look over here, broke this into 4 equal pieces. Our lower rectangle area was this, the upper rectangle area is this, 0.46875. If we add those two together and divide by 2, we get an average of 0.34375. Okay, now what the rest of this table is basically saying is, let's say instead of breaking this into 4 equal pieces, what if we broke this into 8 equal pieces? Okay, so then what we could do is we could go in on our graphing calculator here, and instead of doing these all by 1/4, we could actually go in and do these all by 1/8 instead, right? So if we were going to do the lower rectangles, sorry, it takes my computer a little while to catch up with me arrowing back here. So if we broke this into 8 equal pieces, if we were doing the lower, we would go start from 0 and go up to, not there, go up to 7 equal pieces. Sorry, from 0 to 7 for 8 are 8 equal pieces. And then now our height, instead of being 1/4, is going to be 1/8, which is going to be going to insert 0.125, because that's 1/8. And then we're going to take our x and not divide it by 4, but we're going to divide it into 8 equal pieces. So we do all that, change that up, and we push enter, and that tells us if we were to break it up into 8 equal pieces, we get 0.27344 rounded off right here for the lower. Okay, and then we can go back and do the same thing for the upper. I'll just do that really quick instead of making you wait through here. I'll pause it. Okay, so I went back and got the same thing over again and just changed our 0 to 1 and our 7 to 8, because we're going to, if we're doing the upper rectangles, we're going to start here at the 1/4, 2/4, 3/4, 4/4, or in this case 1/8 all the way up to 8/8, and we push enter there, and our upper rectangles is 0.39844, which is what that would round off to. And then if we add those together and we find the average, we are getting actually a little bit closer to what it would be if we went through and did it all the way to, like, say 10,000. Okay, so this is our approximating the area under a curve using lower rectangles and upper rectangles, and then just finding the average of those two. Okay, so that's one way to do it. On the next video, I'm going to show you how to do that with trapezoids. Okay, if you have any questions about any of this, please feel free to ask in class. Thanks.